Welcome to the wonderful world of astronomy. This video is on types of nebulae, and it goes with the lab on nebula classification. In this video, we'll look at the 5 types of nebulae, and the goal of this lesson is to enable you to, by looking at a photograph of a nebula, to determine what type of nebula it is and to have some ideas of what is happening, what causes it to look like that. The first type of nebula, as you see on the screen, is an emission nebula. An emission nebula is made luminous by the presence of a hot star. Now in the picture, you might not be able to see the star, but there is some star somewhere in the vicinity that's causing it to glow. And what's happening there is the light from the star is exciting the electrons in this cloud of gas, and the electrons go up to higher energy levels, and when they fall back down, they give off certain wavelengths that are determined by whatever elements are there. Now, because hydrogen is the most dominant element that's in the galaxy, and hydrogen gives off red, usually you'll see a lot of red in emission nebulae. Now, not always, and there are other elements that give off other colors, but typically if you see a nebula that is just pure red like this one, it's probably an emission nebula. By the way, as a side note, the word nebula, I forgot to mention, comes from the Latin word for cloud. So these are clouds of either gas or dust up in space. This particular nebula on the screen it's 2 of them, the North American Nebula and the Pelican Nebula. And you can see to the left, the greater one looks like the shape of North America. So there's California, Canada, the East Coast, Florida, Gulf of America, and there's Mexico. So there is North America. And to the right is the Pelican Nebula. You can see he's looking at the East Coast, and there's his beak and his head and his spine and the rest of his body. This is another emission nebula, a good example of that they're not always going to be red. It's called the Rosetta Nebula. Different elements in it are giving off different colors from their spectral fingerprints. And we can determine using spectroscopy, such as this green and this yellow. I can't determine it just by looking at it, but using spectroscopy, astronomers can determine what elements are exactly there. Now, sometimes astronomers are interested in seeing where is the hydrogen. I mean, generally, if you have a cloud of gas in the galaxy, you know it's going to have a lot of hydrogen. And you could just say, well, this red up top, that's probably from hydrogen, but the green, that could be masking some of the red. And so what astronomers do, if they want to know where's the hydrogen, they'll use a filter, basically a red filter, and it'll just show the red from the hydrogen emission lines. So this next picture is the Rosetta Nebula through a red filter. And so here they can see exactly where the hydrogen is. The second type of nebula is a reflection nebula. And here's the Witchhead Nebula. An easy way to tell you're looking at a reflection nebula is it will always be this nice solid blue color right here. Now, whereas an emission nebula is made of gas, and it's gas that's being excited, a reflection nebula is primarily dust. And it is the dust that is scattering blue light from a nearby star. Now, in this particular picture, you can't see the star that light is coming from. The star is actually off screen to the right. It's the star Rigel. And the light from Rigel is coming, it's hitting the dust, and that dust is scattering the blue light, very much in the same way that Earth's atmosphere scatters blue light in all directions. So reflection nebula, easy way to tell you're looking at one is this nice solid blue color. Very often when you have a cloud of gas and or dust, it's going to exhibit characteristics of multiple types of nebulae. And this one here is a combination of emission and reflection. It's called the Trifid Nebula, otherwise known as M20. And at the top of the screen, there's the blue, and this is primarily from dust that is scattering light from a star. So that's a reflection nebula up top. And down below is an emission nebula. That pinkish red is from hydrogen gas. By the way, there is a third type of nebula exhibited here that we'll get to later in the video. It's called a dark nebula, and these black lanes right here are dark nebula. We'll get to those in a bit. Here's another example of a reflection nebula. This is the Pleiades, otherwise known as Subaru, otherwise known as M45. You've seen this picture before, one like it. The Pleiades you learned about in chapter 15, learning about clusters of stars. The Pleiades are an open cluster. But between those stars are a whole lot of gas and dust, and the dust is reflected. I'm sorry, the dust is a reflection nebula. What I meant to say is the dust is scattering the blue light from those stars, and so we get that blue haze that's pervasive in this picture, and that's a reflection nebula. The third type of nebula for this video is a planetary nebula. You've learned about these in chapter 17 and maybe a bit in 18, looking at the end of low mass stars. And after a low mass star has kicked off its outer layers, they go out, usually in a nice symmetrical pattern, leaving the white dwarf in the middle. You get this thing called a planetary nebula. This one in particular is the Cat's Eye Nebula. Now, they're called planetary nebulae because when they were first discovered, astronomers looking through a telescope saw that it looked like a fuzzy circle. It looked like a planet. So planetary nebula has nothing to do with planets, except that early astronomers a few centuries ago thought that they looked kind of like planets through the telescope. Here's another planetary nebula, the Ring Nebula. And you can't see the white dwarf at the center. Well, maybe you can. I'm not sure which one. Maybe it's the one that my red dot is covering. I just don't know. There is a white dwarf at the center. But there's the Ring Nebula. You can see it's got that spherical or circular symmetry to it. And that's an easy way to tell you're looking at a planetary nebula, by a symmetry, often a spherical or circular symmetry. Now, all those pretty colors, they're that way similar to how an emission nebula is formed, where the different colors are given off by different elements that are in the gas. But rather than just grouping it with other emission nebulae, because of its unique way that it's produced from the expelled layers of a star, of particularly a low mass or intermediate mass star, we give them a special category of planetary nebula. This one is harder to see. It's a planetary nebula. It's hard to see the symmetry because, well, sometimes you can't always see it, and there's probably some complicated things going on the inside. It might actually be a double star system, and there's some turbulence in the way the gas is being expelled. So this is a very difficult one to visually identify as a planetary nebula. But I throw this on the screen just so you can see kind of a more extreme version where sometimes they're not always that easy. It's called the Rotten Egg Nebula because it has a lot of sulfur gas in it, and sulfur smells like rotten eggs. So whoever had the opportunity to name it decided that it probably smells like rotten eggs. Here is from the James Webb Space Telescope, a better picture of the Rotten Egg Nebula. Very beautiful colors. Another planetary nebula, one of my favorites, is the Eskimo Nebula. You can see very clear the white dwarf right at the center. Here's the Dumbbell Nebula, has the shape of a dumbbell. It's easier maybe to see the dumbbell in this picture to the left that is not as good of a picture. I put these pictures side by side, the black and white and the color, to show you the difference when you're looking through a telescope with your eyes as opposed to looking at a picture that's been taken. it will look like this, kind of a gray smudge. And most of these things, we have this dichotomy when we're looking, when we're doing astronomy, we see these beautiful pictures on the internet and in textbooks, like the one on the right. And then we look through a telescope with our own eyes and we see something not quite as impressive like the one on the left. And the reason we tend to see this grayishness, not these beautiful colors through a telescope, is that this is an object that's very, very far away, and so very, very dim. And our eyes only gather light for about maybe 1/10 of a second before they refresh the image, and your eyes just don't have the ability to gather all the light that's needed to start to make out all the colors. So you see what's on the left when you look with your eyes. On the right, doing astrophotography, this is a situation where between the telescope and the camera, they leave the shutter open for a long time, maybe an hour or two, and possibly it's 100 different pictures that are taken and then superimposed on each other. So the telescope and the camera have the ability to gather light for a long, long time, and it's only over that long time, maybe many minutes or maybe many hours, that you can start to see those colors. The next type of nebula is a dark nebula. Dark nebula, very easy to spot because it's dark, it's black. It looks like there's something missing. It looks like it's covering over something. Now this is the Horsehead Nebula. And what you see right at the center is what looks like a horse's head. And a horsehead nebula, or I'm sorry, a dark nebula like this horsehead is made of dust. And that's very much like a reflection nebula, also made of dust. Except with a reflection nebula, the dust scatters blue light. With a dark nebula, it's just blocking what's behind it. Very much like clouds in our sky do. When the sun goes behind clouds, you can't see the sun anymore. And so that's what's going on here. You've just got this dark cloud that's the horse's head. Now you see at the top of the screen, it's a dark/emission nebula. You can see the pink-red background behind it, and that is an emission nebula, the first type that I talked about in this video. And so what we see is an emission nebula and the dark horse head that's covering it. Now we can zoom in on the horse head. It looks more like a cloud in the sky, and so you've just got this dust that blocks light behind it. This is another example of a dark nebula, Barnard 68. Looks kind of eerie, looks like something out of science fiction where all the stars have been eaten by this monster. But the stars are not missing. It's not a void in space. The stars are behind it. It's just that it's blocking the starlight. And you can tell, just looking at this picture, you notice at the fringes of it where the nebula is going to be a little bit thinner. Notice that some of the star's light are peering through. It's just a little bit dimmer. Now, to confirm what I'm saying, that it's not a void in space, that there are actually stars behind it, we can look at this nebula with wavelengths of light other than visible light. So in the next screen, we're going to look at this dark nebula, Barnard 68, with not visible light, but infrared light. And here's a side-by-side comparison. On the right is looking with infrared light that is close in wavelength to visible light, but you can see that infrared light from the stars behind it are peering through. Here's another dark nebula. I think it's called the Bat Nebula. Good decoration for Halloween right there. The fifth type of nebula that I'm going to talk about in this video is a supernova remnant. And this is one that is specifically formed by a supernova. So remember from chapter 17, looking at the life of a high mass star, when the core becomes iron and the entire core just shuts down and the star collapses, then explodes outward. This is all of the outer layers of the star exploding outwards, usually a variety of colors because of all the elements that are contained in it. And the most notable feature of a supernova remnant is the thin, wispy strands. And so you can uh, see all these strands right here. It doesn't look very solid, but the thin, wispy strands, this is the Crab Nebula. Here's another example, the Veil Nebula. And those are the different types of nebulae, the 5 different types. So now we're going to go through in this video identifying the types of nebula. So this will give you a good practice as you get ready to do the lab. So let's see if we can identify the different types of nebulae. All right, we're looking at this one, certainly beautiful colors, but you see it's got a circular symmetry to it. And so a good guess here is that it's a planetary nebula. And there it is, planetary nebula. All right, this next one here, let's look at it. Well, there's no symmetry to it, but what we see, it looks kind of like clouds in the sky. Now, they're not dark as in black, but it is actually a dark nebula. And notice, it looks like something that's covering up something in the background. And the something in the background is a blue haze. And so actually what's going on, this one in particular is called the Pillars of Creation. And it is in the background, the blue is a reflection nebula. And in the foreground, the major dark yellowish thing you're seeing is actually a dark nebula. So this is both a dark and reflection nebula. This next one, well, there's no symmetry. You might say there's thin, wispy strands, but they're not really. This one's hard, and here's what's going on. If kind of the catch-all category, if you're guessing what type of nebula this is, and you're absolutely clueless, just guess emission nebula. Because emission nebula, you've just got gas, and it's the gas is being made luminous. The different colors are given off by elements. It's being made luminous by a star that's nearby. And if you can't discern any particular features to it, it's just a nice asymmetrical blob of light, you can guess that it's an emission nebula. Okay, here we see a beautiful symmetry. It's not actually a circular spherical symmetry, it looks kind of like 2 circles overlapping. You see that little white dot in the center, and this is actually a planetary nebula. Here we go, variety of colors, thin wispy strands. This is a supernova remnant. All right, this next one. First thing you might notice is a whole lot of blue. So think about what a whole lot of blue means. Second thing you might notice is over the whole lot of blue is a whole lot of black. And so these 2 types of nebula go hand in hand. There's dust here, and part of it is the dust reflecting or scattering blue light, and part of it is the dust just blocking light. So what we have here is a reflection nebula in the background, that's the blue, and then a dark nebula in front of it. All right, here, the most obvious that you see, no particular symmetry, it's just a whole lot of red, so think what that probably means it is. But then you notice towards the bottom of the screen, you notice there's that black right there and that black, and up at the top of the right screen, that black, and there's some weird stuff here. So what we have is a whole lot of red that's being blocked. And so we've got an emission nebula, but then features of dark nebula in front of it. All right, this next one, you see a whole lot of dark. And so you can guess that's a dark nebula. But look at what that black is covering up. There's a blue haze all around. And so very often these two nebulae go hand in hand, dark and reflection, because they're both dust. But some of the dust is scattering blue light, some of the dust is just blocking light. So it's dark and reflection. This one here is round. You can see there's a little star, a little white dwarf at the center, and so it should be pretty easy to identify. This is a planetary nebula. Okay, and that's the end of this, and that, of course, is Nebula from the Marvel Universe. And to end this slideshow here, a bunch of, they all look planetary to me. Well, most of them look planetary, and you can see down below the scale, the size, 4 light years across. Now think about how big 4 light years is. That is the distance between our sun and the next closest star, Proxima Centauri. So these things can be pretty big. This concludes the lesson. What you should do now is do the nebula classification lab. Have a great day.